What I have here is an exercise sort of buried at the bottom of some strange clunky exposition, which is to cap off all of this discussion of vectors and strings, we should see at least one example of a vector of strings. And I have one of those right here. So here I have a vector called vs, and we can see that its element type is string. So we could read the type of vs as being vector of strings. And here in the initializer, I've got 3 elements. Each element will end up being a string. And so it shouldn't surprise us that I can create a vector of strings because, of course, I can make a vector of any type. I mentioned when we introduced vectors that I could, if I wanted to, and in fact I might want to pretty quick here, I could in fact make a vector of vectors. I can make a vector with any element type I want. And so in this case I have a vector of strings. And as far as the clunky exposition goes, I wanted to prove that I can work with a vector of strings just like a vector of anything else. And so here I'm looping over using a for each loop. I'm looping over for each string s in my vector vs, and I'm going to print it out. I'm going to use it like a string to prove that this vector of strings actually works. So I'll print out what the element actually is. So it should be first raspberry, then pear, then pineapple, and then I'm going to use this string s in a way I could only use a string. So I'm going to try and access a particular character of the string, just to prove that my vector of strings is truly a vector storing actual string objects. So we'll try running that, and then get around to the actual exercise. And we can see it first prints out that the next element is raspberry. If I go to the third character, I shouldn't say character 3, that's sloppy. Third character. So we'll try this. I'm not going to restart the video. You'll just have to live with my grammatical complaint. Okay, so the third character is S. So, 1, 2, 3. Index 2 would be letter S. The third character in the word pear is the letter A. So again, the third character is the one that occurs at index 2. And then the third character in the word pineapple is letter N. So hopefully I've been able to prove that this indeed is a vector of strings. If I go and grab an element of this vector, I am indeed getting a string. And so for the sake of having an actual exercise to do with vectors of strings, why don't we try this one, which is I've got this string called big string. I would like to set big string to be the concatenation of all of the elements in the vector vs. So all of these things. In other words, I want big string to be a single string with raspberry, then pear, then pineapple. And if you think about it, we know that concatenation, we should recall already that that word concatenation should remind us of the plus operator on strings. If I use the plus operator, I am concatenating strings together. And so in fact, what I'm really asking for here is to compute the sum of this vector. I want to add up all the elements in the vector. The difference is I'm not adding up numbers, I'm adding up strings, but I'm allowed to do that. I am allowed to use the plus operator on strings. So I think what I want to do is this. It's actually very similar to the logic I used when I was converting a string to lowercase. I'm going to loop over every string in my vector. So for each string s in my vector vs, I would like to take that string and attach its characters to the end of this big string that I'm building up from left to right. So I use the plus equals operator to add those characters to the end of my big string. And so we'll try saving that, and we'll run this. Now, I know it's sort of a contrived task. The goal of this ultimately is just to prove that vectors of strings can exist and that they aren't so scary. They're just a way of composing one type inside another. And of course, we're going to want vectors of strings all the time in this course because now that we've seen how powerful and easy text processing can be with strings and vectors, we're going to want to do a lot of it. And we can see here the big string is raspberry, pear, pineapple. So I was able to loop over my individual strings in the vector and then fold them all together into one using a for each loop and the plus equals operator.